What's up everyone, welcome back. Patrick here, moving on to another video dealing with factoring. These are going to be some special cases that you may run into. Notice that basically all of these were dealing with higher exponents, and I went through these kinds of cases as well in the previous section, but in the previous section, remember, we were dealing with factoring when that a value is 1. Here that a value is not going to be 1. So starting off with the first one, we got 4x to the 4 plus 19x to the 2 plus 12. And this over here, it's a common case situation that comes up where if you notice that the exponents that you're dealing with, notice that this one, this is the leading expression, it has an exponent that's double this one over here. And that's actually similar to a quadratic, right? Because a quadratic, notice it has an exponent of 1 over here and then an exponent of 2. So this is double that. Well, same thing here, except now we have a 2 and double that is 4. And then another scenario is over here where we have a 3 and then double that is 6, or it could be maybe like 4 and 8 or 5 and 10. So just be on the lookout for these kinds of scenarios. And whenever I run into something like this, what I like to do is introduce a new variable. So what I'm going to do is I'm going to let m equal x squared. Now you don't necessarily have to do it this way. I'll actually show you at the end of this another way you can go about it where you don't introduce a new variable. But personally, I like to because I feel like it just simplifies things a little bit. Now, if m is equal to x squared, then notice that if we square both sides, what we do to one side, I've got to do to the other, we'll have m squared is equal to x to the 4, right? 2 times 2 is 4 here, and then we just have this m squared. And so notice that we could plug in m squared for this x to the 4, and then we could plug in m for this x squared over here. And so what we could do is we could rewrite this expression as 4m squared plus 19m plus 12. And now notice that we took this and we were able to simplify it into a quadratic. And this we know how to factor, right? So whenever you have this kind of relationship with the exponents, as we see in part C as well, you can always introduce a new variable and bring it down to a quadratic, a format that you're more comfortable with. And then from here, you can just factor this as usual. So first thing we look for, can we take out a greatest common factor? Notice in this case we can't. And so let's do decomposition. So we have a value of 4, we have a b value of 19, a c value of 12. AC is equal to 48, right? 12 times 4. And then what two numbers multiply to that AC value of 48 and add up to that B value of 19? That would be 16 and 3. And so now we could just decompose this into 16m plus 3m plus 12. From these two, we could take out a 4m, and we're left with m plus 4. And then from these two, we could take out a 3. We're left with m plus 4. And then we could take out the m plus 4, and we're left with 4m plus 3. Now notice that this final answer here, it's in terms of m, and our expression is in terms of x. So once we get here, we have to bring back that x squared. So notice we'll have x squared plus 4, and then 4x squared plus 3. So that right there ends up being the final answer. Now the other way to do it, if you didn't want to bring in a new variable like this, you can actually do decomposition from there. It would still be these two numbers, 16 and 3, so the a value would still be 4, the b value 19, c value 12. You do that process. Let me actually keep this last line. And so what you would do is you would just decompose this. So we'd have 4x to the 4 plus 16x squared plus 3x squared plus 12. And from these two, we could take out a 4x squared, and we'd be left with x squared plus 4. Right? If we take out a 4x squared from this, we end up with x squared. If we take out a 4x squared from this, we end up with just a 4. And then we could take out a 3 from these two. x squared plus 4. Then we could take out the x squared plus 4. And we're left with 4x squared plus 3. Right? So notice the exact same solution. Okay, so multiple ways to go about it, but personally what I like to do is, so we're not dealing with too many exponents, like notice here this factoring by grouping can get a little bit more tricky when you're dealing with higher exponents. Sometimes it's inevitable to do. You'll see in part B we'll have to deal with these exponents because that's going to be a multivariable expression, for example. But if I can simplify it, then I usually go that route. All right, but whichever way you do it, that's what part A factors to. Now, what about part B? We got 6x to the 4 minus 11x squared y squared plus 5y to the 4. Okay, so this is a multivariable expression that we're going to factor. First thing, as usual, we check for a greatest common factor that we could take out. Notice between the 6, 11, and 5, there's no common factor between that. Notice we have x's here, but there's no x expression here. We have y expressions there, but then there's no y expression here. All right, so there's no greatest common factor we can take out initially. So what if we try decomposition? So we'll have an a value of 6, a b value of negative 11, a c value of 5, and then we multiply the ac. That would give us 30. Are there two numbers that multiply to positive 30, add up to negative 11? And notice there are negative 6, negative 5, negative 6, negative 5. Right? Negative 6 times negative 5 is 30. Negative 6 plus negative 5 is like negative 6 minus 5, which gives us negative 11. So then we could decompose this into those two values. Now be careful because we still have these exponents attached. So these are just the coefficients of what we're going to decompose this into, but we still have those exponents like that. Okay, so from here, factoring by grouping, so from these two, we could definitely take out a 6. Notice we could also take out an x variable, and the lowest exponent would be x to the 2. Can't take out this y variable because there's no y variable there. And so what would we be left with? What you could do is you could take each of these and divide it by what you're taking out. The 6's cancel out. X to the 4 of x to the 2 is x to the 2. Divide, divide, those cancel out. Those cancel out. We're just left with a y squared right there. Then from these two, we could take out a minus 5y squared. And so if we divide this by negative 5y squared, divide this by negative 5y squared, that would be positive 1. The y's cancel out. We're just left with an x squared. Positive 5 divided by negative 5 gives us negative 1. Y to the 4 over y to the 2 just gives us y to the 2. And then we could take out an x squared minus y squared, and we're left with a 6x squared minus 5y squared, like that. Right, so that right there ends up being the final answer. Now you can actually factor this further, but we haven't covered it yet. It's a difference of squares. We're going to cover that in the next section, but technically this also factors into x minus yx plus y, this bracket over here. So you may see the solution. If your textbook or teacher hasn't covered a difference of squares yet, you may see the solution like that. But if you see the solution like this, these three brackets, just know that what happened was we took this expression, factored it into those two brackets. And so we will be running into scenarios like that in the next section. Now moving on to part C, we got 9x to the 6 minus 15x to the 3 plus 4. So this is again one of those situations where we have an exponent here, and then this leading expression has an exponent that's double this one. Okay, and whenever this happens, what I like to do is introduce a new variable to simplify this into a quadratic because it has that same pattern as a quadratic in terms of the relationship of the exponents. So I'm going to let m equal x to the 3, and that means that m squared would equal x to the 3 squared, right? If we square both sides, so m squared is equal to x to the 6. So we could sub in for the x to the 6 and the x to the 3. The x to the 6, we could sub in the m squared. And then the x to the 3, we could sub in an m. And then we got a plus 4 like that. And then from here, we can just factor by decomposition. We could have factored by decomposition again, just like part A. From here, I'm not going to do the second method in this one. If you want to try the second method, you can. Just make sure that the final answer you're getting is the same one. So from here, notice we can't take anything out initially. From the 9 and 15, we could take out a 3, but 3 is not a factor of 4. So let's go straight into the decomposition. AC would be 36. Two numbers that multiply to 36 add up to negative 15 would be negative 12 and negative 3. Negative 12 times negative 3 is positive 36. Negative 12 plus negative 3 is negative 15. So then we could decompose this into those two values. From these two, we could take out a 3m. We'll be left with 3m minus 4. From these two, there's a negative here, so we're definitely going to take out a negative 1 at least, but then between the 3 and the 4, we can't take anything else. So we're just going to take out a negative 1 from these. Basically, all of the signs are going to change. Then we could take out a 3m minus 4. And we're left with a 3m minus 1. Okay, but remember, it's not in terms of m, it's in terms of x, the original expression. So now for this m here, we got to bring back this x to the 3. So when we do that, we'll end up with 3x to the 3 minus 4, 3x to the 3 minus 1. So that ends up being the final answer. Again, if you want to check any of these, like with all factoring questions, you can expand this. And when you expand this, you should end up with that original expression. Okay, so that is part C. Let's split this up here. Now let's do part D. So first thing we always check, greatest common factor. Notice there's a lot going on, and notice that the x variables, it's in all the expression, and the y variables are in all of the expressions. But also notice that between 30, 14, and 4, we could take out a 2. There's a negative here, so I'm actually going to take out a negative 2. Now between the x variables, 5, 3, and this is like a 1 here, the lowest exponent is a 1. And then we got a 3, 5, and 7 for the y, so we can take out y to the 3. That's the lowest exponent. And so what would we be left with in the brackets? Well, we basically got to take all of these. When it becomes a little more complex like this, you could even do some work on the side, which I would probably recommend. So what would be the first expression here? Well, we would take this first expression divided by what we took out. Negative 30 divided by negative 2 gives us positive 15. X to the 5 over x to the 1 gives us x to the 4. And then these would cancel out. So we'd end up with a 15x to the 4 here. And then we got the 14x to the 3, y to the 5 divided by negative 2x, y to the 3. So this would end up being negative 7. This would be x to the 2. This would be y to the 2. So we end up with minus 7x squared y squared. And then we'll have a 4x y to the 7 over negative 2x y to the 3. This would be negative 2. The x's cancel out. And we got a y to the 4. Like that. So we end up with that right there. Right? And then from here, as usual, let's see if that remaining bracket will factor further. And I'm pretty sure that it will. Okay, this becomes just like part B that we factor. So we can't take out any greatest common factor because we already did that. So let's see if this would factor by decomposition. So A value is 15, the B value is -7, the C value is -2, the AC value is -30, two numbers that multiply to -30 and add up to that B value of -7. And those two numbers would be, what, -10 and 3? That works, right? -10 times 3 gives us -30. -10 plus 3 gives us -7. So then we could take this middle term here, decompose it. Just be careful with these exponents. Don't forget them. Plus 3x squared y squared minus 2y to the 4, like that. Okay, and now we factor, so let me actually just erase this, give myself some room. So from these two, we could take out a 5. We could also take out an x squared, right? X is common, take out the lowest exponent. There's no y here, so we can't take out any y variables. 15x to the 4 over 5x squared. If you were to do some work on the side, divide those, we'd end up with 3x to the 2 minus 10 divided by 5 is 2. The x to the 2's cancel out. We'd just be left with a y squared. Now from these two, from the 3 and 2, we can't take anything out, but y to the 2, y to the 4, we could take out a y to the 2. So what would we be left with? 3x squared minus 2y squared. Right? If we take both of these expressions divided by the y squared, we'd end up with those two respective expressions right there. I didn't do the side work for this one, but if you want to do the side work just to confirm this, feel free to do so. It's a good habit to have. Takes you a little bit longer, but minimizes mistakes. And as expected, a nice check, as usual, that we have is those two brackets should always be the same, which they are in this case. So we take out those two brackets, and we're left with 5x squared plus y squared, like that. Okay, and then these, none of these are a difference of squares. As you'll see in the next section, these don't factor further, like in part B it factored further. But that's a check you always want to do. Again, you'll have the tools to do that in the next section. So this is this bracket factored, but don't forget that we still took out that greatest common factor in the beginning, so the final answer ends up being that greatest common factor multiplied by these two factors right there. Right? So that ends up being the answer to part